When we solve systems of equations, there are three possible outcomes. The first type of solution that you could have is when you graph two lines and there's a point where they intersect. This is when you have one solution. There's one solution where the systems are going to intersect and there's one point that's going to make both true. The second type of solution you could get is when you have two lines that you graph that turn out to be parallel. Parallel means that there's no solutions. There's no places that these two graphs are going to cross. There's nothing that's going to satisfy both equations. And the third option, when you graph the two lines, you could have them be the same line. This means that there are infinitely many solutions because the two lines are just different forms of the same line. Let's look at a couple examples. Number 1. When we're looking at a systems of equations, we need to have at least two equations to consider. So in this case, we're given y equals negative 1/3 x minus 1 and 3y equals 4x minus 18. If we want to solve the systems of equations graphically, then we need to graph both of these lines. So our top line right here, we have y equals negative 1/3 x minus 1. So our slope is negative 1/3 from our value right in front of the x, and our y-intercept is 0, negative 1 from our b value from our slope-intercept form. In order to graph this one, we'll start with our y-intercept of negative 1, and then our slope says negative 1/3. So that means we go down 1 and we always run to the right. So down 1 and over 3. Down 1 over 3, down 1 over 3, down 1 over 3. There we go. We can connect our dots. There we go. And let's look at our second line. In order to graph this one, we first need y equals. So to get y equals, let's divide every single piece by 3, and then we'll have y by itself. If we divide everything by 3, we have 4/3 x minus 18 divided by 3 is 6. Our slope is 4/3. Our y-intercept is 0, negative 6. So we can plot that one. So 0, negative 6 is right here. 1, 2, 3, 4, 5, 6. And our slope is 4/3, so that means we go up 4 and over 3. 1, 2, 3, 4. 1, 2, 3. So right there is going to be where they cross. But let's draw another one so we can draw our line. 1, 2, 3, 4. 1, 2, 3. We can connect our dots. And now we can see our solution. Our solution is where these two lines cross, which in this case is right here, and our point is 3, negative 2. So this means if I were to put 3, negative 2 back into both of these equations, that's the one point that will make both equations true. Let's try another one. Number 2. 2x minus 5y equals 10, and y equals 2/5 x minus 2. So same thing, the first thing that we need is our slope and our y-intercept. I need a little bit more space for this one, so let's work on it down here. So 2x minus 5y equals 10. So I want to solve this for y equals. So let's subtract 2x from both sides. And then let's divide everything by that negative 5. So we'll divide every piece by negative 5. And we'll get y equals, I like to have the x term first. So negative 2 divided by negative 5 is 2/5. X, 10 divided by negative 5 is negative 2. So we have y equals 2 over 5x minus 2. So that means that our slope is 2 over 5, and our y-intercept is 0, negative 2. If we graph, we start with our y-intercept of 0, negative 2, so 1, 2. And then 2 over 5 means we go up 2, 1, 2, and over 5, 1, 2, 3, 4, 5. Up 2, over 1, 2, 3, 4, 5. We can draw our line. There we go. And now let's do the other one. Well, notice, look what we have right here. Look what we have right here. So our slope is 2 over 5. Our y-intercept is 0, negative 2. These are the same equations. This was just a different form of this one. So if we were to draw this line, it's going to perfectly overlay the purple line from the first one. So this means that these are the same line. So there's infinitely many solutions. Let's try again. Let's say we have, for number 3, x minus 1/2 y equals 4, and 2x minus y equals 4. So let's solve these for y equals. We'll do the top one first. We'll put it right here. So we have x minus 1/2 y equaling 4. So let's move our x over. So negative 1/2 y equals negative x plus 4. I need to get rid of this negative 1/2 right here. So I can do that by multiplying everything by negative 2. So if I do negative 2 times negative 1/2, that's just going to give me y. If I do negative 2 times negative x, that's going to give me positive 2x. And negative 2 times positive 4 is negative 8. So this one, our slope is 2, or 2 over 1, and our y-intercept is 0, negative 8. So 0, negative 8 is way down here at the bottom of the graph. Negative 1, 2, 3, 4, 5, 6, 7, 8. There we go. And our slope is 2 over 1. So we go up 2 over 1, up 2 over 1, up 2 over 1. There we go. And let's do our next one. So for this one, we need y by itself, so let's move the 2x over. So we have negative y equals negative 2x plus 4. We can divide each piece by our negative 1. So y equals 2x minus 4. Almost the same. Look right here. The slope is the same, but minus 4, minus 8, those aren't quite the same. So for this one, our slope is 2, or 2 over 1, and our y-intercept this time is 0, negative 4. So 0, negative 4 is 1, 2, 3, 4 right here. We go up 2 over 1, up 2 over 1, 2 over 1. So these two lines have the same slope but different y-intercepts. If you remember from our previous chapters when we looked at drawing the equation for parallel lines, we said that parallel lines have the same slope. Well, these are parallel lines. They have different y-intercepts, but they're parallel, so that means that they are never going to intersect. So in this case, there would be no solution.